This is topic 15-1, quadratic parent function and parameter changes. Our essential question today is how can I sketch the quadratic parent function and investigate, describe, and predict the changes in a and c on the graph of y equals ax squared plus c. So the changes we're discussing is a is the number in front of the x squared and c is the number that's being added on the end. Our bell work today is to complete the problems on making the connection worksheet number 10. Our two problems that we're doing is which is the best that represents the function y equals x. Y equals x, this is a linear function. You can type it into your calculator and see what does that graph look like. So you go to y1, type in x, and look at the graph, and that will let you know what the linear function looks like. Linear function, this is going to be c. This y equals x is also actually the linear parent function. So let me add that to it. That means all other linear functions and all other linear graphs are derived from starting with that y equals x. So number 2, in a sense, is asking the same question, except instead of giving you an equation, it's saying which graph best represents the linear parent function. So 2 possible ways of asking the same question. And again, you need to understand that the linear parent function is y equals x. If you understand that, then the correct answer is going to be J. If we look at F, let's talk about y. It's not. This is a negative sloped line, so this actual equation is y equals negative x. Even though it's a linear function, it is not the parent function. G has a horizontal line going through the y-axis, so it has an equation of y equals, and unfortunately I can't read that number, so it's some number. Again, yes, it is a line, and it is a function, but it is not the parent function. H, a vertical line going through the x-axis, so the equation of that line is x equals whatever number it is going through. Well, this is a line, however, it's not a function, and again, it's not the parent function. So J, notice, looks just like the graph on C. C is a sketch, but J is the actual graph that you get on the grid. So let's talk about the quadratic parent function today. So we're going to make a table and actually graph it. To make a table and graph, we will use our calculators. So at this time, please get your calculators and turn them on. So now that you have your calculator, we're going to go to y equals because we actually are given an equation. This is y equals, and we're going to type in x squared. X is next to the alpha button, and then the square, to make it squared, we go 1, 2, 3 down from the alphabet, and you actually see an x squared. Press enter. We have now inputted the parent function for a quadratic equation. So I'm going to write on here that this equation represents the parent function for quadratics. Now, when you look at your grid that we are given here, notice this grid, there's no numbers on it. It starts off at 0, 0. If I count up, here's my y-axis, and it's going up to 10, going down to negative 10. On my x-axis, I'm going to positive 10 and going to negative 10. So this is the standard graph in which we go from negative 10 to positive 10 on both the x and the y-axis. So when we graph these, we are going to be dealing with the standard graph. So when I go to draw my pictures, I have to choose the numbers that will fit that graph. So first, let's get a preview of what we're going to be graphing. As you see, it kind of looks like a U, and it's going through the 0, 0, or going through the origin. We want to make sure that we can graph both the left side and the right side. And so let's go and look at the table. So we'll hit the second and then graph. Bring up our table. In our table, we have numbers starting at negative 10, but notice the y value is 100. I cannot graph that on my grid. So I'm going to continue to go down until I can find y values that I can actually graph on my grid. and I get to -3 and I see, yep, 9, I definitely can graph on this grid that goes up to a +10. So I'm going to start off with -3 for an x value. My y value is a +9. X value of -2 gives me a y value of 4. -1 gives me 1. 0 is 0. 2 is 4. I skipped 1. So let's try that again. 0, 0. +1 gives me a +1. +2 gives me a +4. And +3 gives me a +9. So we just used our calculator to get our table, but let's say you don't have a calculator. Where did these numbers 9, 4, 0, 1, 0, 1, 4, 9 come from? They came from the equation. To get the y value, we plugged in the x value and squared it. So this 9 comes from taking the -3 and squaring it will give us a +9. The 4 came from taking the -2 and squaring it and getting a +4. We just allowed the calculator to do it for us. So now we're going to graph the points. From the table, we know that the x-coordinate is -3 and I have a y-coordinate of +9. So starting at origin, I need to go 3 to the left to go x -3, and I'll go up 9 on the y direction to get to +9, and that gives us the point -3, 9. Then we'll do -2, 4. So x -2, y is a +4. Doing -1, 1, so x is -1, y is a +1. We got our 0, 0. When x is +1, y is +1. When x is +2, y is +4. And when x is +3, y is +9. Now I'm going to connect the dots so that I get a U-shaped graph, just like what was on the calculator. So I'm going to move back to my graph, and sure enough, I have a U-shaped graph like was on the calculator. Now to answer the questions as far as domain and range, domain, recall, means what x values are being used in order to graph this picture. Notice we put arrows on the ends of our parabola or our picture, our quadratic picture, because it means that my grid stops at 10, but the graph doesn't stop at 10. And I know that because when I look at the table, I can continue going on and on beyond +3 to a +9, and you'll see that those y values continue on. So when it's asking what the domain is, it's saying, are there any values of x that I cannot put in here, put in that equation? Are there any values of x that I would put into this equation and come up with an error in my table? And it turns out there are none. I could continue to go up and up and up, or down and down and down, and I will always get a number in the y column. So the x values that are used in order to graph or to create the graph would be all real numbers. Instead of writing out all real numbers, I can use this is a fancy R, and that fancy R stands for all real numbers. So you can either write out all real numbers, or you can use the fancy R. So if the domain is your x values, you know your range are your y values. The y values that are being used in order to graph this particular quadratic. So what y values are used? If you look at the quadratic, notice that it is opening upward, and I don't have any part of the quadratic down in the third or the fourth quadrant. So I don't have any negative y's that are being used. I can also verify that by looking at my table. I look when my numbers are negative, notice all the y's are positive. And if I go down and look when my x's are positive, my y's are also positive. So this shows me that all the y values that are being used are all positive. So I'm going to look at the smallest y value we have, and that is at the origin, and recognize that all the values of y that are being used are the ones that are bigger than that. And so our range is y is greater than or equal to 0, because 0 is the lowest y value in the table. So I'm going to go ahead and draw an arrow to that. The vertex, your vertex is either going to be a maximum or minimum point. The vertex in this particular case for the parent function is the lowest point on the graph. The lowest point on the graph is that 0, 0. So I'm going to label this 0, 0 the vertex. You can also see it on the graph. That's the vertex. So when it's asking for the vertex, it's going to be the lowest point on that graph since it opens up. I can even draw me a little helpful hint picture and say it's that point there. So this is your parent function of a quadratic. Your quadratic functions, any other quadratics that you draw or equations that you come up with are always going to start with this particular parent function. The graph itself, or the picture of it, this is known as a quadratic. I'm sorry, it is named a parabola, or some people like to say parabola. But the graph itself is called a parabola. The equation is called a quadratic equation or quadratic function. So now, let us compare. What is the difference? We're going to compare a linear function to a quadratic function. So what we know about quadratics, we're going to just write in this last column what we just found out. Our equation for the quadratic is f of x equals x squared. Or you might see it as y equals x squared. F of x is function notation, but mainly you see x squared is the equation. The picture that we came up with was it looks like a U with arrows on the end, continuing going upward. Then we got our domain, our range, and our vertex. So the domain, we said all the x values are being used to graph it. The range, only the y values that were greater than or equal to 0 are being used. And the vertex was the lowest point or the minimum point on the graph, and that was 0, 0. If I think of linears, our linear equation, we recalled from our Bell work, was f of x equals x, or you might see it as y equals x. The picture, it's a positive slope line. We have arrows going on. The domain for the line, notice all the x values are being used and all the x values are being used and all the y values are being used. So that means our range and our domain are all real numbers. The line continues on forever and ever due to those arrows at the end. The vertex, it does not have one. There is no maximum or minimum point on the line, because any point I find on the line, I can always see, hey, there's arrows, there's going to be a point that's bigger or smaller than that point. So there is no vertex. At this time, I want you to get out 2 colored pencils. In addition to the pen or pencil that you're currently using, if you can get out 2 colored pencils or 2 different color highlighters, it will be very helpful. So pause the video and find your 2 highlighters or colored pencils. Once you have that, we're going to use the calculator in order to graph our parent function, and then we're going to see what happens when we change some parameters in the equation. So the very first graph that we draw is going to be the parent function. And it's what we're actually sketching it. So I'm going to put a little dot with my pen or pencil that I started off with. And remember that the parent function went through the vertex went through the origin 0, 0. I can do that better. So here's my vertex at 0, 0, and then I'm going to draw a U. Now I'm going to use the calculator to see what happens when the number in front of the x squared changes. So with the original parent function, the number is an understood 1 that we don't have to actually show, but we can see that our second equation is now 2x squared. So using the calculator, we're going to type in 2x and then squared, press enter, and we're also going to type in into y3, 5x and squared. And so now you have your 3 equations. I want you to add something to your notes what you're going to add to your notes is you're going to hit the zoom button and then the number 6. Let me show you what happens when you hit the zoom button. Number 6 stands for, you see it says it's a zoom and you want a standard window. The standard window is the window that goes from -10 to +10 on the x-axis and -10 to +10 on the y-axis. The other great thing about this zoom 6 is that when you hit the 6, it will graph your parabolas for you. And the first parabola is graphed, that's your y1. Second parabola is graphed as the y2. And the third parabola that's graphed is your y3. So you get an idea of what's happening with the 3 equations. So we saw the first graph was our y1. Second graph was when we put a 2 in front of the x squared. And the third graph was when we put a 5 in front of the x squared. So I'm going to show that again. Now right now if I go to y equals and I hit graph, it's just going to show me the graph. However, if I hit the zoom and then 6, I can see them graphed in order. So here's my original parabola. This is with the 2 in front of it, and then this is with the 5 in front of it. So you can see as those numbers are increasing and getting bigger, the thing that's happening to our graph is the graph is getting narrower. So with your different color pen or pencil or highlighter, I'm going to choose one. I have green, and my y2, I'm going to draw it as a green parabola. It does still go through the vertex. It comes on up. And then with the y3, I'm drawing with a pink one. And again, it goes through the vertex and comes up. So I have 3 different parabolas in 3 different colors. And using my legend over here on the left, I know which color goes with which graph. So now let's talk about the observations. Notice we put a number in front of the x squared. So if I have a number in front of the x squared, and that number is greater than 1, because I went to 2 and then the 5, we notice the graph got narrower. Another thing that, another way that it is described is to say the graph gets narrower, but another way that it can be described is the graph is being stretched. And it's being stretched in the y direction. So vocabulary that you need to know for here is that it's getting narrower and that it's being stretched actually means the same thing. Example 3, we have our original. So with my original pen or pencil, I'm going to draw the original going through the origin and a U. And now we're going to look at what happens when the number in front of the graph. Notice these are fractions. So I'm going to say the number in front of the x squared is a positive fraction. Now let's find out what happens with our graph. Go to y equals. My first equation stays the same. Second equation now is going to be 1/2. So it's a fraction. I'll do 1 divided by 2. And then times x squared. And I forgot my division sign. Second graph, we'll clear it out. In parentheses, we're going to do 1 divided by 5. That's the fraction. And then x squared. Press enter. So now to see these graphed in order, we'll do zoom and 6. Here's my original. This is 1/2 in front, and this is 1/5 in front. So we notice that the 1/2 is a little bit wider, and the 1/5 is even wider. So in this case, our graphs are going to get wider. And if you notice, the one half, or I should say, the 1/2 is bigger than 1/5. Or let me think of it this way. The 1/5 is smaller than 1/2. So if it is smaller, the smaller it is, the wider the graph. Whereas in problem 2, 5 is bigger than 2, so the taller it is, the more narrow it's going to be. So if it's getting wider, we also say that the graph is being shrunken, or the graph shrinks in the y direction. So now let's draw those pictures using your 2 different colors. So I'm using pink for my half of x squared, so it's a little bit wider. Then I'm choosing another color for the 1/5, and it was wider than both those other 2. Three graphs, 3 different colors, we can see the difference. Number 4, we only have 2 equations in this one, so let's go ahead and draw our initial graph. Goes through the origin, looks like a U. And now let's look what's happening to the equation. What's happening to the equation is the number in front is negative. Again, there's an understood one there, we just don't show it. So we're going to say, what happens if the number in front is negative? Well, let's find out. Using a calculator, go to y equals. First equation stays the same. Second equation now changes to a negative x squared. There is no third equation, so I'm clearing it out. Do a zoom 6. Here's my first equation, original, and here's the negative in front. So with the negative in front, we see that the graph is flipped. So one description is to say it's flipped. Another description is to say that it is reflected. You may see it mentioned that it is reflected. And another description that I will typically use is that it opens down. So the difference between the two is our original is opening up and makes a U or a valley. Our new one is going to open down and make a peak. So choosing a different color, I'm going to draw my parabola opening downward. Let's get some arrows on here showing that they continue on in the downward direction. Still goes through the origin, but now it's being reflected across the x-axis, or it was flipped, or now it's opening downward. Okay, our last example has to do with what happens when I add or subtract a number on the end. So if I'm adding or subtracting a number on the end, this comes after the x squared. So I'm saying add, subtract, number after the x squared. Let's find out. Let's start off with our original. Opens up. Now we're going to input the 2 equations and find out what happens to our picture. First picture stays the same. Second picture, or second equation, it is now positive x squared, and then we'll put plus 5. And our third equation is x squared, and now minus 5. We'll do a zoom 6 to see what that looks like. So here's our original. Here's our plus 5, and here's our minus 5. So I'm going to do a little trick so we can see a little bit better what that looks like on the calculator. With younger eyes, you might be able to actually see it a little bit better. So here's my original graph going through 0, 0. The plus 5, if I look, it actually moved up 1, 2, 3, 4, 5 spaces. This is now at a positive 5. The third one that was drawn, if I count, it actually moved down 1, 2, 3, 4, 5. So this vertex is now at a negative 5. It's no longer at 0, 0. So using this information, I'm going to now draw my two pictures. Again, choosing a different color for my Y2. That's the one that went up 5. Since this is sketch, I don't have to be so accurate. I can show it as well above. And then I'm going to make a note that this is now at 5. If my pen will work for me. We'll just do a different color. And now my third graph, different color, it's pink, and it moved below. This is now at a negative 5. So what is happening with our graph is that when we add a number on the end, it shifts the graph up by whatever that number is. When we subtract a number on end, it shifts the graph down, however many, whatever that number is. So I'm going to go ahead and write that over there. So if we add, we shift up. If we subtract, it shifts the graph down. So now we are going to summarize what we have learned. In the general equation, a squared plus k. So I changed the variable to a k. That's okay. Down here in our objective, it was a c, but it's okay. We're looking at if a is the number in front of the x squared. If that number is negative, in example 4, we saw that the graph will open down. It opens down, or we can say it's flipped, or we can say it was reflected. If a was a fraction, and this is saying a is between 0 and 1, that means it is a positive number less than 1. That's all that means. That's a positive number less than 1. So I'm looking for a fraction that is positive and less than 1. This is like example 3. We saw that the fractions caused our graph to get wider. So it's wider, or we can say that it shrinks. If a, again, the number in front of the x squared, is greater than 1, so I'm looking for a positive number and it's greater than 1, this is like example 2, what happened to our graph is our graph got narrower. So narrower, or we can say it was stretched in the y direction. So the first 3 deals with the number that is in front of the x squared, and it basically is going to change how the parabola looks. So a negative will give you it's going opening down. If it's a fraction that is positive, it's going to make it wider, and if it's bigger than 1, it's going to make it narrower. Now the k is the number that's on the end. And so I'm adding k. If that k is a positive number, that's like the first part of example 5. If it was positive, it shifted up. You could also say it moved up. If k was negative, again from example 5, we know that it shifted down. So the next ones are examples that give you examples of what's going on with the graphs itself. And some of you may or may not need this in order to do your assignment. So it is okay for you to stop the topics right now and actually start working on the assignment. These next examples are only to help you if you get to a point on the assignment and you can't figure it out, then come back and actually watch this part of the video. So I give you permission now to conclude the topic 15.1 and start the assignment. If you need help on the assignment, then we're going to do these examples. So number 6 says start with the graph of y equals x squared. Notice that's your parent function, and you want to write an equation that will make it wider. If I'm making it wider, that means I have to shrink it. And if I'm shrinking it, that means I need a number in front of the x squared that is going to make it smaller. So as long as it is a fraction that is positive and less than 1, we are shrinking it. So I'm going to use 1/5. 1/5 x squared. To make it narrower means we need to stretch it. So in order to stretch it, I need to put a number in front of the x squared that is bigger than 1. So let's make that a 5. Your number might be different than mine as long as it's bigger than 1. If I want to move it up 3, that's the same as saying shift it up 3. So I take my original y equals x squared. To move up or down, it's going to be on the end, and since I'm going up, it is a positive. So we add a positive 3. To move it down, we have going down makes it a -4 at the end. Number 7 says the graph of f of x and g of x are shown. F of x is the x squared minus 7, and it wants to know what is the graph of g of x. So my question has to do with g of x. I'm going to highlight it to make sure I understand which graph I'm trying to find the equation of. So they give you the one for f of x. F of x is -7, and we see that the vertex has been shifted down 1, 2, 3, 4, 5, 6, 7. G of x looks exactly the same, except it has been shifted up. And when I talk about moved or shifting, I am starting from the origin, which is where parent function began, and seeing how far did it move up or down from that origin. So from the origin, g of x went up 2. So g of x moves up 2, which means our equation then for g of x is going to be x squared. I moved up 2, so plus 2 on the end. Number 8, we have f of x is x squared plus 3, and it is shifted down 6 units. What would the new equation for the translated function? There's a couple ways that you can do this. One is algebraically, so I'm going to show algebraically, and then I will also show how to do it by sketching a picture, and then you can decide which one works best for you. If I am shifting down 6, that means I have to subtract 6 from the x squared. So I am actually going to subtract 6 and rewrite the equation. It's still f of x. X squared doesn't change, but a positive 3 and -6 gives us a -3. So here's our new equation to show that translation. I could also draw me a little sketch. It says my original is at x squared plus 3. That tells me, hey, I'm starting out 3 above the origin. It now wants me to shift down 6 units. Well, I know to get back to the origin, I have to go down 3. And so that's 3. I need 4, 5, 6. Here's going to be my new vertex after moving down 6. And I see that is now at the -3 point. And it does match what I just did algebraically. Number 9, how does the graph y equals 2x squared plus 4 compare to the graph of y equals 2x squared minus 1? I'm going to, again, sketch me a little picture. 2 just means it's being narrower, but the plus 4 means starting from the origin, I'm going to go up 4. So 1, 2, 3, 4. Again, it's a sketch, and I'm going to label that that is 4. My second graph, again 2x squared, that's the same, but now it's at -1. So going down, here's 1, and then sketch my graph and label that's -1. Now let's look at the information. We have the graph of 2x plus 4 is 5 units above the graph of 2x squared minus 1. So the key here is that it's 5 units above. Well, let's see. 2x plus 4 is above the minus 1. And if I was counting, it would be a total of 5 units. So A actually is the correct answer. But let's look at the other two just so you can see why the other two are not, or the other ones are not. We have 2x squared plus 4 is 3 units below. If I look at my picture, plus 4 is not below the minus 1, so B is no good. The graph that has the plus 4 is 5 units to the right. We have not shifted anything to the left or the right, and so I immediately know C is no good, and then D has left, so I know D is no good. That is one of the things, we are not shifting left or right, so if you ever see it's moving left or right, we can immediately toss those out. Number 10, the graph of y equals 11x squared plus c is a parabola with the vertex at the origin. So if I look at it, parabola with the vertex at the origin, which of the following must be true for the c? So the plus c tells us how the graph is moved, and it'll move up or down depending on if c is positive or negative. So A says C is greater than 0. That means C must be positive, which means it should be moved up from the origin. Ours is on the origin. Make a better picture of that. So A is no good. B, C is negative. That means it has to be moved down from the origin. Again, ours is on the origin, so B is no good. If c is equal to 0, that means our equation is just y equals 11x squared. There is no movement, and it stays at the origin. So yeah, that's a possibility. That looks good. D, we have c is equal to 11. It gives us a number, so y equals 11x squared plus 11 would mean that it has to be moved up 11. Ours is on the origin. It's what it says, the vertex. So D is no good. Our answer then is C. When we're matching graphs, you have an equation, you're trying to match the graph that goes with the equation. So we have 3 graphs that are opening up and 1 graph that is opening down. So D, I'm going to go ahead and write. This is opening down. If it's opening down, that tells us that the number in front of the x must be negative. Okay, number in front of the x squared. I need you to make a correction. I just see it on number 11. That should be 2x squared. So now I'm going to do a description from the equation and then see how it matches what I see on the pictures. On the equation number 11, it has a 2x squared. The 2 in the front tells us that, hey, I'm stretching this, I'm making it taller, so it's going to be narrower. Number 12, we have a negative that tells us it's going to open down. And then the plus 2 at the end tells us I have to shift it up 2 or move it up 2. Number 13, it's already positive, so it's opening up. Let me go ahead and show that 11 is opening up also. It opens upward, and the only other thing that's changed on from the parent function is the minus 2, so that means we had to move it down 2 from the origin. And then 14, I have a 1/2 in front. That means I'm going to shrink it, which means it's going to be wider. So 12 is the only one that opens down, and we see that it is shifted up 2, so we know that 12 is equal to D. Once I have it, cross it out. Let's go at number 11. I'm looking for something that's narrow, but it does go through the origin. I have 2 of them that go through the origin, A and C. C is the narrower one, so C goes with 11. 13, it's opened up, but it's moved down 2, so we see yes on B. It did shift down 2, so 13 is B. And 14 says it should be wider. but it's at the origin, and the only one that's left is A. You will see it definitely is wider than C. It's still at the origin, and so A is our answer. Okay, that should help you on your notes, or sorry, this should help you on your assignments if you needed it. This concludes topic 15.1.